So what I'm going to do now is just do the same experiment, but I'm going to investigate a parallel circuit. And obviously with one lamp, that's the same arrangement as a series circuit with just one lamp. So what I've got is, again, 6.4 volts is giving out by the power supply, and this lamp is getting 6.4 volts. So all of the energy, the electrons are being given 6.4 joules per coulomb. So they're being given 6.4 volts worth of potential energy by the power supply, and that lamp is using that up. Now what I can do is add another lamp in parallel this time rather than series. And the lamps are lit again. And what I can do is I'm just going to measure the voltage. So 6.35, so roughly 6.4 volts. This lamp here seems to be as bright as it was originally, and it's still got 6.3 volts worth of energy. And indeed, if I connect across here, I've also got the same 6.2, 6.3 volts worth of energy. So what you have to consider is that electrons that leave the power supply here and go through this component, so the electrons leave the negative terminal of the supply. Now they're given 6.3 volts worth of energy, or 6.4 volts worth of energy, but the only components that those electrons that go through this lamp meet is the ones as they go through here. So the only resistance that they meet on this way through here is this lamp here. So they deposit all of their energy there because they don't meet, the electrons going in this route here don't meet any other components. Whereas the electrons that are going this route only meet this component, so they deposit all their energy here. So they only have that one component to deposit all of their energy. If I add another lamp in here, then they'll still be equally bright. And what you can see is as I connect it up, so this is 6.3 volts from the power supply. This lamp is getting 6.3, 6.2 volts, lose a little bit in the wires. 6.2, so 6.2, nearly 6.2 as well. So all of these lamps are getting their full allocation of energy. So they're all receiving the same energy as given out by the power supply, because the electrons only pass through one component, be it that lamp, or that lamp. They don't pass through all three as they did in the series circuit, so they had to use some energy in each of the components. We're going to investigate the voltage in a parallel circuit. So again, we start with just the one lamp. So this is the same as the series circuit. We've only got one lamp in it, and the voltage that's given by the power supply is 6.4 volts, and the voltage that's given by this is used by this lamp is 6.4 volts. We can now add another lamp into there and see what the effect of that is. So I'm going to put another lamp in parallel. And put a voltmeter across there to measure the voltage. And what we did when we measured this is that actually this voltage here had dropped slightly. So this was now 6.3 volts. It was slightly smaller. This one here got 6.3 volts. And this one here got 6.2 volts. So it got slightly less, tiny amount less. It's probably due to the extra wires it's got to go through using a little bit of the energy. But what you can see, hopefully, is that the voltage is very similar from the power supply to this lamp and this lamp. And if we consider the routes that the electrons can flow around, so we've got electrons leaving here with 6.3 volts worth of energy, and they only meet this one lamp, so that's the only place they can deposit that energy. They don't go to this lamp, so they don't deposit any energy there. And then this second route, the electrons flow along here, and again, The ones following the green route, they only go through this lamp. So that is the only place they can deposit their energy. So they've deposited 6.3 volts here and 6.2 volts here. As I say, the wires, we normally ignore the wires, but they will take a little bit of energy to push electric current through. So to check this, I've added a third lamp in parallel. So there's 1, 2, 3, and I've missed the voltmeters off now just to make the diagram a bit easier to see. But you can see that the power supply is giving 6.3 volts of potential energy. So 6.3 volts of electrical energy is going through here. And we've got 6.2 used in this lamp, 6.2 in this lamp, and 6.1. And as I say, the wires will take a tiny amount, but the rule is that the energy from the power supply is equal to the energy used across each branch. And you can see there that this one and this one are very, very similar voltages to there. And again, that is because electrons only go through one of the lamps. They don't go through 2 or 3, they only go through one of the lamps. So they only deposit their energy at that one lamp.